Hey guys, Dr. Brown here with Kubo Math coming to you from Tarlac City, Philippines. I have a cold. You probably can detect that in my voice, so bear with me as we walk through this. But I wanted to work a few more problems associated with the FOIL method. There was some feedback as to people said they'd like to see more of that. So here we go. So FOIL, you'll remember it dealt with the first, outside, inside, and last. So we're multiplying the first. So in this case I have x plus 3 times 2x minus 1. So x times 2x gives me 2x to the second power. And then the outside, so x times a negative 1 gives me a negative x. Inside, 3 times 2x gives me plus 6x, and then a positive 3 times a negative 1 gives me minus x. So now I have 2x to the second power minus 5x, plus 5x minus 3. So I had a negative x plus 6, a positive 6x gives me a positive 5x. So that's just one example of how the FOIL method works. So let's keep going. Now a plus 3 times the parentheses a minus 3. So a plus 3, a minus 3. The first times the first, I have a times a, which is a to the second power. Then I do the outside, so now it's a times a negative 3 minus 3a. And then the inside, so these two, so a positive 3a. And then the last, 3 times a negative 3 is a negative 9. So you'll notice a negative 3a and a positive 3a, those two terms cancel. And I have a to the second power minus 9. Now eventually you'll get to where you will know how to factor. We'll teach this on how to get from this back into that, and it's called factoring, and you need to be able to do that, but we'll get there. In this case, number 3, I have a plus 3 to the second power, and you recall when we had a to the second power, that meant, well, I'm going to call let's call it x, that'd be better. So x to the second power means this times itself 2 times. So that's x times x. Well, same as this. I have a plus 3 times itself 2 times. A plus 3. So now let's do the FOIL method. First times first, it's a to the second power. That's a times a, plus the outside, which is 3a, 3 times a, plus the inside, which is also 3 times a, plus the last, which is 3 times 3, which is 9. So I have a to the second power plus 3a plus 3a is 6a plus 9. Okay, let's look at number 4. Now in this case, I have a parentheses that I need to utilize the distributive property. Recall, we had a times a parentheses of b plus c, meant I'm going to distribute that a times b plus a times c. So it gives me ab plus ac. So we have to do that same thing here. So I have 3a plus, distributing that 4 to the inside, 4 times 2a gives me 8a, and then 4 times a negative 3 gives me a negative 12. So 3a plus 8a is 11a, 9, 10, 11, and then minus 12. So that would be my answer, 11a minus 12. Okay, in this case, number 5, 2x plus 1 plus 4 minus 3x. Recall the associative property of addition. Now I have it written here. The parentheses of a plus b plus c is equal to a plus the parentheses of b plus c. You have that same scenario here. Everything is added. Now there is a negative here, but I'm adding that parentheses. So it's 4 plus 4, plus 4, but also plus a negative 3x. So I can remove those parentheses. 2x plus 1 plus 4 minus 3x equals 10. Well, if I collect the terms, 2x minus 3x gives me a negative x. 1 plus 4 gives me a positive 5 equals 10. Well, I don't want to know what negative x is. I want to know what a positive x is. So I'm going to add x to both sides. So I have a negative x plus 5 equals 10 plus x. So a negative x and a positive x cancel, and I'm left with 5 equals 10 plus x. Well, I don't want to know what 10 plus x is. I just want x. So I'm going to subtract 10 from both sides. 10 minus 10 plus x equals 5 minus 10. So I subtracted 10 from both sides. So a negative 5, well, this 10, that 10 cancel. 5 minus 10 is a negative 5 equals x. Now let's just see if we're correct. So x equals a negative 5. So a negative 5 here, a negative 5 here. 2 times a negative 5 is a negative 10 plus 1. So there's my 1 plus 4 minus, and 3 times a negative 5 is a negative 15. So a negative 10 plus 1 is a negative 9 plus 4 minus a negative 15. What's minus a negative? It's the same as plus a positive. 4 plus a positive 15 is a positive 19. Minus 9 plus 19 is 10. And that's what we needed. 10 equals 10. So we do know that x equals minus 5 is the correct solution. But what about this problem up here? Now it's very similar to what we just worked, except I have a negative out here. Recall the associative property is associated with addition. How do I handle this negative? So I have 3a plus 7 minus a. I have to distribute that negative into the parentheses. So it's minus a. A negative times a negative is a positive. So it's a negative opposes this negative, so it's plus 1 equals 14. So 3a minus a is 2a plus 7 plus 1 is 8 equals 14. So now 2a plus 8 minus 8 equals 14 minus 8. I need to get rid of my associative property for a moment. So 14, let's see, 8 minus 8 cancels, so I have 2a equals 14 minus 8 equals 6. I don't want 2a, I want 1a, so let me divide both sides by 2. 2 divided by 2 is 1. 1 times a is a. 6 divided by 2 is 3. So let's plug this back in to see if we're correct. 3 times 3, let's see, so everywhere there's an a, it's 3. 3 times 3 is 9. 9 plus 7 minus 3 minus 1 is 2. 3 minus 1 is 2, so minus 2 is what's inside that parentheses. So 9 plus 7 is 16. 16 minus 2 is 14. Yay. So those are just examples of the FOIL method, utilizing the associative property for addition and the distributive property for not just multiplication, but also distributing the negative inside and getting the proper sign on numbers inside the parentheses. Study your math. You're going to hear me say that every week. Study, study, study the rules and be able to recognize when you apply what rules to what calculations. Hopefully this helps, and keep studying those rules, because together we want to make a better world, and we can do that if we just keep studying, studying, studying. So sorry for the bad voice tonight. Hopefully I get over this in coming days, and then we'll talk to you soon. Take care. Thanks.